Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's webcast, Healing 8 Power Management Pain Points, brought to you by Information Week, Eaton, and broadcast by United Business Media Limited. I'm Jenny Zaino, and I'll be your moderator today. We have just a few announcements before we begin. This webcast contains audience polling. The polling question will appear in the slide presentation window. Please complete the poll when they appear, and click on the Submit Answer button located on the polling slide window. Thanks in advance for your participation. You can participate in the Q&A session by asking questions at any time during this webcast. Just type your question into the Ask a Question text area below the video window, and then click the Submit button. At this time, we recommend you disable your pop-up blockers. The slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the Download Slide button located below the presentation window. If you're experiencing any technical problems, please visit our Tech Webcast Help Guide by clicking on the Help link below the media player. In addition, you can contact our Technical Support Helpline, which is also located on the Technical Webcast Help Guide. Now we're going on to our presentation, Healing 8 Power Management Pain Points. Discussing today's topic is, and if somebody could push the slide for me, that'd be great, Jeff Ames, Senior Business Unit Manager, Distributed Power Quality at Eaton. A 16-year veteran of the power systems industry, Jeff is focused on the adoption and deployment of critical power protection strategies in information infrastructure environments. We also have with us Lawrence Cruciana, President and Chief Systems Engineer at Corporate Information Technologies, Inc. Jeff, I'm going to hand it over to you to begin the presentation.
Very good. Thanks, Jenny. I appreciate the introduction. Hello to everyone out there today. As Jenny introduced, we are going to spend the next 40 to 45 minutes or so going through a presentation here about healing 8 power management pain points. We're going to run through advice for solving common power management problems, hopefully an introduction to a number of intelligent power management solutions, and then we're going to leave hopefully on the order of 10 to 15 minutes of Q&A at the end of the session. But before we get started here, we have our first poll question, and Jenny, if you'd like to guide the audience through the poll, that'd probably be a good thing.
Okay. Well, the first poll question today is, how many different building management or data center infrastructure management systems does your organization use today? And your choices are none, 1 to 2, 3 to 4, or 5 or more. And we'll just give everyone a few minutes to put their answers in order on that one. And I don't know, Jeff, if you've got some idea of what they might be based on your past experience.
Yeah, I have a feeling this is going to trend up towards the up on the upper end of this thing, but we'll see here as the audience poll actually comes in.
Okay. Give them just one more second here, and I think we've got a decent representation coming in. And interesting. Let's see if we can push those slides out there to see the results.
All right. Okay.
Okay, there we go.
So sort of right in the middle.
Yeah.
Although no one's in that 3 to 4 range. We have quite a few who seem like they're in the 1 to 2 range, but quite a number who have quite a deployment of building management systems and data center infrastructure management systems. And surely, what we'll be talking about here today is certainly a portion of that, and I think it'll kind of play in a little bit with maybe solving and simplifying some of the complexity that's out there. So let's kind of walk here onto the next slide. So 8 power management pain points. I'll kind of walk through these things here. So From what you'll see on the next few slides here, we've got a little cutaway of a typical data center, maybe with a little bit wider 50,000-foot view than some of you are accustomed to seeing, which actually showing our the data center in the middle there, surrounded by a number of the power infrastructure elements that you might see associated with a data center. And let's just kind of walk through certainly what we want to talk about here today is some of the pain points that you might be encountering in your data center. So among the first ones we'll talk about here is aggregating power quality device information, monitoring and managing virtualized server environments, protecting workloads during power outages, maintaining power system reliability, administering remote data centers, tracking power quality assets, managing use-based electricity billing schemes. This was one that seems to be a real hot topic, at least for us here lately, and configuring firmware updates for your deployed power resources. So let's kind of walk through these one by one here. So pain point number one, which we've identified, which we wanted to address here today. So what are we seeing as customer requirements out there? So complete real-time status information from every device across the network, whether that is power quality equipment like UPSs, power distribution equipment, gensets, anything that might be involved with your data center power infrastructure. Some of the particular nuts and bolts details that you might be running against out there, you've got power quality devices with no connectivity cards, no network communications, no visibility to devices outside of a single data center, and you might actually have standalone power management solutions which are causing you problems. Well, some of the intelligent power management systems that are out there today can solve those by giving you a global view of all network-enabled power devices, even those without connector cards. There's schemes that can be employed out there so that you can serially connect through protected systems and aggregate all of that information into a single dashboard. There's solutions that can give you visibility into the data center and beyond. And there's auto-detect functionality that allows you to auto-discover all of the various network-enabled devices that are out on your network. And certainly the ability to put all of that into tree structures to group and display those in whatever organizational format suits your particular needs. So another poll question here to push out. Looks like we actually got this one slightly out of order here, but let's go ahead and run through it anyways here. How much of so the poll question that we've got hopefully is visible on your screens here is a question to kind of gauge virtualization as it's hit your local data centers. Roughly how much of your organization's server infrastructure is virtualized at present?
That'll be an interesting one to see.
Yeah, go ahead, Jenny.
No, I was just going to say that'll be an interesting one to see, especially as more mission-critical applications wind up getting virtualized. It'd be interesting to see how high that number is spiking compared to where it might have been, not that long ago.
Okay, we'll wait just another minute or so and see how the poll results are coming in.
I think we're going to have some interesting findings on this one.
I'm just waiting for it to refresh on my screen. And we're getting interesting answers here.
Yeah.
We'll wait another half a minute or so here to let those last poll results come in.
Looks like we've
So I think we've pretty much
some information
at this point, which is interesting because we're hearing a lot of certainly a lot of promise on the virtualization front, and it's certainly what we are getting calls on a day in and day out basis. There's certainly a lot of, I'm sure Jenny, Information Week is spending an awful lot of press talking about virtualization. Sounds like this particular audience is seeing probably opportunity for it. Maybe you just haven't deployed it yet, and we probably should have been a little smarter and deployed a poll question here on future looking, whether you're planning on doing it in the next 12 to 24 months. That's usually the poll question that really spikes up. Well, it looks like about half of you have virtualized very little of your server environment, and then probably another, probably a third to a half of you in that 10 to 50% of your installations that you virtualized. That's going to play in here in just a little while when we talk about virtualization as it applies to your power infrastructure. Let's move on here to kind of pain point number 2. Should be hopefully refreshing on your screen here. Is it coming from your screen?
I think we've got it.
Okay, very good. It's not appearing on my screen, so that's okay. There we go. So monitoring and managing virtualized server environments. So like I was saying, this has become, obviously a very large trend for the power industry here recently. A lot of discussion about virtualizing server environments. But one thing that oftentimes gets forgotten is the physical power infrastructure that's the backbone of supporting those virtualized power environments, and what needs to be done to fully take advantage of the virtualization that you've done on your server environments. So some of the customer requirements that are typically being seen out there is having unified control over virtual servers and the power management systems that support them. But some of the real challenges that are being seen is that there's little to no integration between power management systems and virtualization management systems. That there's a lot of lost productivity and oftentimes delayed response times, which can be a problem when you're looking at mission critical power. So with today's intelligent power management systems, some of the things that you can expect to see out there in this environment is tight integration with leading virtualization management and load balancing products. I'm sure probably most everyone on the phone is well aware of VMware's products and Microsoft and Citrix products as well. What you can really expect to see is power management software tightly integrating with that virtualization management software. Having the ability to view, manage and administer physical and virtual servers, as well as the power infrastructure like UPSs and power distribution products through one console. And then additionally, within your virtualization like vConsole, for example, in VMware, being able to get a unified view of alerts all in one dashboard. What you would also expect is, in order to take advantage of the promise that virtualization delivers of being able to virtually migrate machines, one of the things, certainly most virtualization deployments are coming about as a result of dynamic server loads needing to be migrated from one physical server to the next. But certainly another type of event that can cause a trigger into that are power events, and that's what you want to be able to see as well with tightly integrated power management, intelligent power management devices, is that you'll have that integration with live migration virtualization systems that will automatically and trigger things like vSphere to be able to move virtual machines during power outages. And you want to be able to do that even in situations where you've deployed platform as a service as opposed to just software as a service. Okay, so this will kind of bring us into pain point number 3, which is protecting workloads during power outages. This is certainly for us in the power industry. This has always been our mission number 1. Ever since our industry kind of came into being 40 years ago or so. The customer requirement is always prompt server shutdown during power outages. And one of the challenges, a lot of companies today do this manually. They don't take advantage of what is offered in intelligent power management solutions. using things like built-in load segmentation, load shedding that come built into a lot of your power management products, be they UPSs, be they power distribution products. Many of these hardware products offer load shedding, load management capabilities that you can put into play during a power event. And what you want to be looking for in your power management products is the ability to fully support that, to manage and monitor your critical loads, shut down your least essential systems first, saving whatever energy storage that you have, be it battery, be it flywheel, whatever you might have deployed. Save those most critical applications until last. And today's intelligent power management solutions will do that, as well as during that shutdown process, being able to do that gracefully, being able to shut down applications, gracefully flushing out your caches, shutting down operating systems as a final step to preserving your data integrity. Okay, another pain point that we collectively see in our data centers of all shapes and sizes, whether your data center, for those of you who are out there on the phone, I'm sure we all have data centers that we're attending to of all shapes and varieties, whether your data center is a single rack full of gear sitting in the network closet, or whether you've got a 30,000 square foot data center that you might be attending to. Maintaining the power system reliability of that data center is certainly a key element of your job. One of the big customer requirements that plays into this is looking for advance warning of future trouble in your power system reliability. Some of the challenges that you're running into out there is limited notification ability and limited access to reporting data. So again, what you should be looking for in today's, intelligent power management solutions that wrap around all of these products is certainly real-time notifications via whatever mode of communication best suits your particular environment, whether that's email, network pop-ups, old school pager alerts, whatever it might be. Being able to receive real-time alerts is certainly a tremendously core piece of power management software that people in our environment are looking for. Other elements in there of collecting performance data across your power products so you can see trends that might be affecting you in the future. The collection of various parameters out of your power protection products. Whether that's UPS products of all shapes and sizes, being able to report the functionality that helps should you ever have a problem, being able to collect and database the information that might help on-site technicians, be they your own staffs or outsourced staffs, to proactively identify and address any of the issues that are affecting your environment. Moving on, the fifth pain point that we wanted to address was administering remote data centers. One of the requirements that we really see coming out there from the folks that we talk to on a day in, day out basis is the ability to manage multiple data centers across multiple locations. I'm sure many of you are involved in data center mirroring or co-location. You have your physical assets and your compute assets really deployed across a wide range of geographical locations. And some of the challenges that I'm sure that you are up against is that your management tools might only support one site at a time, or that your management tools require a dedicated workstation physically residing in the facility that you're managing. And today's generation of intelligent power management solutions, you really can kind of step beyond that, and you now have the ability to monitor and control network-enabled power devices wherever they might be. Again, through very simplified dashboards, anything that's IP-enabled, you can really kind of collect all of that information into one location and put those in tree structures as you need to manage it much as you would manage your compute assets. Certainly web-based interfaces are also available for most of this class of product, so that you don't need to be network connected to your physical network environment. You can do web-based access as well. Along those lines, I'd like to introduce my co-speaker, who was briefly introduced by Jenny up at the beginning of the session here. Lawrence Cruciana, you still connected with us, Lawrence?
Absolutely.
Lawrence is the President and Chief Systems Engineer of Corporate Information Technologies, Inc. Lawrence, maybe you can bring this home a little bit for some of the audience with some of your experiences in this arena.
Absolutely. I appreciate it, Jeff. And good afternoon, everyone. As you heard, my name is Lawrence Cruciana. I'm the President and Chief Systems Engineer of Corporate Information Technologies. We are a business technology consultancy and enterprise or VMware enterprise partner located in Charlotte, North Carolina. We help businesses of all sizes, from small to small enterprise, to accomplish a lot of their technology goals, primarily in the areas of virtualization on VMware platforms, implementing data storage systems, establishing and defining comprehensive disaster recovery and business continuity plans, as well as designing and implementing secure network infrastructure. What I'll be talking about today is a challenge that we had run into as we had watched and observed the widespread deployment of virtualization, and specifically VMware, in the clients that we had that had very high uptime requirements. So at the time, we were using a competitive power management software solution to that Eaton provides. And we had seen that there were some inherent limitations in that, and essentially that competitive solution only permitted us to shut down virtual machines in the event that there was a power outage. It wasn't VMware aware and really couldn't take advantage of any of the inherent benefits or technologies that were present in that virtualized platform to help sustain the virtual machine's operation. So since it wasn't aware of any of these other computing resources, we knew that we really had a problem, and so we started looking for a solution. And what we had found a whole bunch of information and doing a lot of research on this that this market is a very dynamic one. And we had seen reviews from places like CRN and several others that on the Eaton product, but like we do with any new product that we introduce to our clients, we brought it into our lab and tested it ourselves. And that was kind of a shock to our Eaton representatives because they weren't used to that. Well, we brought it in and really kicked the tires, and specifically around the Intelligent Power Manager, or IPM. We were very, very impressed. What we had found is that software had given us truly 1 point of power management. It was completely VMware aware. It actually has a vCenter, if you're familiar with the VMware platform, a vCenter snap-in so that you can see and manage all of your power resources through the vCenter client. And I think what was most impressive, and kind of touching on a point that Jeff made earlier, was that the IPM software, it could leverage the other resources that were present in the environment through the enterprise that it was aware of to utilize things like vMotion or live migration to move VMs onto non-affected servers during a power event or if something needed to be taken down for maintenance. And I think that's a point that is often missed here is sometimes power systems have to be taken down for maintenance, and that can cause just as much of an issue as an unplanned and unscheduled power outage. What we ultimately ended up with the IPM solution is it allowed our Network Operations Center to see in real time all of our clients and the status of the power systems there, so that if there are power events, we can discriminate those very discreetly and say that this is a power event, not a server or a VM event in the event of an outage. And we can be alerted with very specific power events when those occur, and we can again deploy appropriate resources or notify our clients appropriately, and can understand the difference between a power event and something happening in the virtualized environment. As a result of all of this, we really helped our clients to achieve their uptime goals, and just try to hit that 5 nines availability of continuous uptime. That's kind of our story. It's been an interesting deployment because we've had now numerous successes with this, and for us as as a systems integrator and technology consultancy, when we have something that actually does what it says it does, that was a really nice and pleasant surprise for us. So with that, I'll turn it back over to you, Jeff.
Okay, thanks, Lawrence. Hopefully that kind of brings things home a little bit, and certainly encourage. There's a number of you that are tossing in questions that we'll get to at the end of the session here as we move into our Q&A. And certainly, if there's any that you'd like to direct towards Lawrence, he'll be here to answer questions as well. Okay. So why don't we push on here to pain point number 6 that we talk about in the context of today's intelligent power management solutions. Tracking power quality assets. Certainly for all of you in the IT community, this is probably one of the banes of your existence in tracking your compute assets and tracking your network assets. And not sure how many of you always get involved in tracking your power quality assets, but it may be falling to you as well. We certainly have people that we work with where that is a pain point for them. So certainly just want to bring out the tracking power quality assets, the requirements that are out there. Again, complete and accurate records of the various power products, including the locations where they physically reside. And some of the main challenges that have historically been out there is the limited ability to identify new or relocated devices. Very similar things to what probably the majority of you are dealing with your compute resources. So what you can expect from in today's class of intelligent power management solutions is tools for recording moves, additions, and retirements, as well as relocations. Visibility across the network, the ability to tag and identify all of your various IP-enabled devices that you've got tied into your systems. You can certainly expect that you would have seamless interoperability with your asset management systems. Having the integration between your power management systems and your asset management systems is something that's developing as well. So we've got our third poll question here, and then Jenny, maybe just give my voice a break for a second and have them listen to someone else. Why don't you take them through this one?
Well, we definitely love to hear your voice, Jeff, but I'll be happy to do that. So our final polling question for today is, how widely does your organization employ use-based electricity billing schemes? And you've got a bunch of options there. Either you don't employ them at all, you're thinking about it, you're planning it, or maybe you employ them a little, or maybe you employ them a lot. So if everyone could just take a couple of moments and give us your input on where you are with that. I think we might find that there is an overwhelming answer to.
We have a winner.
We have a winner. So let's see if we can push those results out to the group.
Yeah, let's refresh one more time here before I push. Doesn't really change all that much. So yeah, and I think the answer to this really kind of depends on the type of organization that you're attached to. This certainly, for the audience that's on the phone here, for the most part, you're not currently using electricity billing schemes inside of your organization. A certain subset of you are investigating them or are employing them. We certainly see this with our colo clients, with our larger enterprise clients. But even when you get down into small and medium business, just interdepartmental tracking and allocation of compute resource, using electricity consumption as a proxy for that has kind of become into vogue with some of the client base that we see out there. So again, one of the pain points that we have is managing use-based electricity billing schemes, where clients are looking to collect, whether it's, like I said before, division level, department level, organization level, usage statistics, again, for the colo types of applications out there, for those who are actually deploying physical assets, on a customer by customer basis. This is certainly a big play. And the real challenge is that current systems can't really group and track power devices by division or by location. And that's what's coming out and again in today's generation of intelligent power management solution is the ability to group all of those power devices, all that power consumption, by whatever organizational hierarchy you decide to put into play. Again, be it customer-based, internal customer-based, or external customer-based. Getting group-level reporting capabilities and the ability to configure real-time notifications based on those usage levels. Excuse me. Having support for mass hardware upgrades as a part of that as well is also an issue that we're seeing. I think I've missed one slide here. No, I don't think I have. That's the ability to push out firmware updates to those sets of clients who are utilizing that electricity-based monitoring scheme is also an issue that we see again coming up again and again and again that is built into today's systems. So again, I'm going to kind of recap here a little bit of the summary of a number of pain points that we've talked through here before we open up the latter portion of the presentation. So we walked through eight different pain points. We talked about aggregating power quality device information. We've talked about monitoring and managing virtualized server environments, and from the questions that are coming in, I can see that there are some that are surrounding that. Protecting workloads during power outages and maintaining power system reliability. Administering remote data centers and tracking power quality assets. Managing use-based electricity billing schemes, and finally configuring firmware updates out there for your deployed base. So I think at this point, if I slide this, I'm going to open it up for Q&A.
Actually, Jeff, if I could just interrupt you before we do that. We've got a feedback form that's opened up on folks' computers, and it would be great if they could just take a look at that, complete the form, press the Submit Answer button at the bottom of the page, and we appreciate everyone's filling this out for us because their participation certainly does allow us to better serve you. And now we can go on to the question and answer portion of the event. And as a reminder to everyone, if you've got some questions you still want to ask, just type it into the text box that's located below the media player window and hit the Submit Question button, and you'll pop up in the queue. So if that is helpful to folks, let's start in with the Q&A part. And it looks like we have a question for Lawrence to begin with.
Yeah, and I'll let me go ahead and I'll read this one. That's right, Lawrence, you can see this as well, but let me pop this one over to you here. So there's one in here that I think is kind of particularly intriguing, which is how large of an infrastructure, and the context of the question from the submitter here is how large of an infrastructure in the terms of number of machines or CPUs is necessary to make a solution like this practical?
Well, that's something I have a lot of experience with. Again, we work with clients of all different sizes, anywhere from 5-person office to 5,000, and everything in between. I think power management and power quality is essential. I mean, one of the things I used to have the misconception of a UPS is a UPS is a UPS. And that's something that is absolutely not the case. Jeff, to the point that you made in a lot of these slides about remote monitoring and management and control of deployed assets, that makes a huge difference. And being able to understand when things like there are issues that are compromising a UPS, like a failed battery or poor power quality in a particular area of a facility. So I think when we start looking at the question like how large of an infrastructure does it make sense before you have to start looking or start considering some of these things, I think any from the aspect of VMware or a virtualized platform, I think any virtualized platform can benefit from this. Even if on the smaller side, if you don't have the multiple virtual hosts in the environment, but you may only have one physical server that is hosting multiple machines, even the ability to intelligently suspend the running virtual machines in the event of a power outage can make a huge difference as opposed to just pulling the plug on it or not gracefully shutting down the physical machine running VMware or Citrix, Microsoft, what have you. So I think it really is as small as one vhost going up to the largest deployments, and we have very successfully deployed this in a 20-person company that had a single vhost running only a development environment, but that development environment ultimately went to QA and production. So small to large.
Interesting. Thanks, Lawrence. That's I think again, for an audience like this, where we never quite know who's out there, whether you're representing super large enterprise environments or whether you're representing a perhaps a small business that you're running yourself. I think that's probably a good bit of color there from you, Lawrence. Appreciate that.
Exactly.
Let's see. I'll take the. There's one in here. I think Lawrence is kind of. I think, Lawrence, you've really kind of addressed that first question that you and I can both see here on how does Intelligent Power Manager integrate with VMware. I think you kind of got that in your discussion. So let's see. We got a second one here, which is: do the management systems you talked about only support virtual machines running on VMware, or do they work with other suppliers of virtual machines as well? For the one certainly that we provide, our system, which is called Intelligent Power Management System, actually does work with both Microsoft and Citrix VM systems as well. The first ones we came out with for sure were tied into the industry leader VMware, but we've since aligned with Microsoft and Citrix as well. Let's see. What other questions do we have here that I can kind of take?
There is a question here about tracking and monitoring power devices that have no network interface card.
Let's see. How can I track and monitor? Okay, so there's a question in here. So this is probably referencing we put in here, and perhaps it was a little cryptic in the presentation, about how can I track and monitor power devices that have no network interface card. How can I, if it doesn't have an IP address, how can I track it? So basically, the way that gets deployed is your power infrastructure device. Let's say it's a UPS or a power distribution unit. You end up having it serially connected into a localized server or workstation. As long as that server, workstation, PC, whatever you have that power device connected up to serially or USB, the IP address of the compute device that it's attached to will come through and be brought into the Intelligent Power Management Systems. Okay. Let's see. What's next on our priority list here, Jenny, that we haven't tackled yet?
Well, there was an interesting one here about whether you can, in addition to using your solution, the IT infrastructure, can you kind of somehow work with building facility systems? I thought that.
Yeah, and it's always on a case-by-case basis, but that's certainly something that we get pressed into service on a day-to-day basis, is how can we embed into facility management systems, how can we pass information back and forth between facility management systems. And that's certainly a capability that's built into the Intelligent Power Management System. And since that, I think that's probably going to get a little technical if I go down into that. We'll probably leave that one. If someone out there has a particular question, certainly either in your survey results or as follow-up, we'll try to contact you about that. There was another one out here, and I don't know if. Yeah, let's take this one. There was one out here regarding the opportunities for virtualization are definitely out there for servers, but the cost of beefy servers and the PMS to support them are almost always cost prohibitive. Yeah, and this is probably more of a comment for virtualization in general as opposed to power management devices or infrastructure power management systems. Yeah, well, I tell you what, let me pass this one over to Lawrence. Is there any comments that you want to make out there about virtualization in general, maybe not so much connected to in power management systems, but virtualization in general and how it relates to having to deploy larger compute systems as a result?
Absolutely, and that's something that we get tasked with all the time. More and more, we are being asked to be more green, if you will, in data center design, and in virtualization readiness assessments that we've done recently. Almost always, and let me qualify that, almost always in environments that have more than 5 to 6 physical servers that would be candidates for virtualization, the implementation of a single, newer, and more highly efficient server system almost always trumps the power cost. And when you combine that with things like with IPM, you have smaller UPSs, less air conditioning you have to worry about, all the inherent benefits of virtualization. So yes, you do need the larger, beefier servers, but in the fact that we're in this age of maddeningly fast CPUs. And those beefy servers don't necessarily have to be as large as they were even a year or two ago, because of the computational resources almost always are trumped by disk. I/O is usually where the limiting factor is, not so much in CPU. So those servers can be much smaller than they have been in the past.
Yeah, and Lawrence, maybe related to that, there's a kind of a new one that's come in here, and probably a perfect tag on here. I don't know if you're refreshing your Q&A screens like I am here, but one of the ones that's up there is with power management software and the shutdown of systems. How long would it take to shut down a system, to shut down a center of 900 servers that have Oracle databases? I'm not sure that even I could answer that one. I don't know. Maybe you can give some color to it with some of the sizes of deployments that you've done.
I definitely can. We have just recently actually been engaged with a similarly sized deployment, and we found that in some of the legacy systems that order matters in shutting them down. So we had established failover orders so that using IPM, if cluster A is unavailable, then move to cluster B, then move to cluster C, and then in an event, shut it down. Well, a lot of times, and again, speaking from my experience with VMware, a lot of times shutting down that many systems can take a prohibitive amount of time if we don't have backup gensets or we're now on a battery on a battery basis, so we have to get these things shut down. So in the VM environment, we found that being able to suspend those machines, those running machines, and then be able to bring them back up in a controlled manner following that power event was actually more advantageous than shutting down, in this instance, 900 servers. So the deployment that we went through, we had a total of 680-something servers that we needed to take down, and we found some of them could be shut down in time, some of them would just be suspended. And again, fortunately, with I hate to sound like a broken record here, but with IPM, it could make that determination so that a human operator wouldn't necessarily have to make that determination, because obviously, if seconds matter, no one can move a mouse quite that fast.
All right, great. Wow, that's awesome, Lawrence. I wasn't expecting you were going to have the exact similar experience. So hopefully, whoever was asking that question out there, you and he are kindred spirits, I guess, in this particular case.
It was something that when it came across my desk, I was very surprised that we had to have that type of conversation. But sometimes you have to do it.
Yep, exactly. There's a question in here about mentioning, probably I glossed over kind of fast, what kind of reports that you discussed can help me spot potential problems before they happen. What you'll typically see in these types of packages is a lot of the alarm reporting, status reporting out of the various power infrastructure devices that you've connected in and discovered via the system. So you can maintain data logs over however long of a time that you want to maintain. And if you start typically I'll take UPSs for example. If you're starting to see a lot of hits where your UPSs overnight are going onto battery, and you actually print out a report at the end of the week, and so you come in during the day and you didn't realize any of that has happened because your UPS is recovered and doesn't look like anything's going on. You can spot those issues before they happen, whether it's with your power quality infrastructure, with your your building power infrastructure, whatever it might be. It gives you sort of a physical record that you can go back to help yourself, your support staff, or again outsourced third-party staff to really identify what issues you might be having with your physical power infrastructure.
There's also a question here about firmware updates and how they work with the new power management systems. Maybe that's one you'd like to take on too, Jeff?
Yeah, sure. With a lot of the, as with servers and network commuting devices, firmware upgrades are available all the time. What this generation of intelligent power management system allows you to do is for those disparate power quality devices that are deployed out there on your network, you can actually use the intelligent power management system as a conduit to push out and deploy those firmware updates on your power quality resources. So again, it saves you from going out and having to do it physical device by physical device by physical device, much as you would avoid that process in your compute environment. Let's see. I think number 9 we were going to take offline. Let's see.
How about giving folks some direction who want to read a little bit more about intelligent power monitoring?
Yeah, boy. Well, you always hope for this question, I guess. This is like the biggest softball that we've got out there. Where can I find more information about intelligent power management? And I swear, everyone, this is actually a question.
It's not a question. It is real.
Yeah, for sure. You can, for Eaton's intelligent power management, you can go to eaton.com/intelligent power. We'll get you there, or eaton.com/PQ will get you to our power quality site. Okay. Are there...
A new one's just come in, if you want to take a stab at it. It's asking about how does IPM define or generate power utilization information from servers that don't have power management capabilities activated?
How does IPM define, generate power utilization information from servers that do not have power management capabilities activated, not connected to IPDUs? Okay, so and so there might be some confusion here. So IPM is typically collecting information not off of power-consuming devices, but off of power distribution and power control and power quality devices. So what you can see is, we actually have classes of software as well, where you can actually bring in the internal power utilization information off of each and every server. Typically, we found that that's a lot more data than most of our clients are really willing or interested to look at. So what typically gets collected and aggregated and reported upon in a product or a class of product like intelligent power management systems is to kind of put a fine point on it, what all of those compute devices are actually plugged into, where they are receiving their power from, whether it's inside of your rack, the power distribution device that's inside of your rack distributing power out to all of the discrete devices. Most of those power distribution hardware devices have, almost all of them have strip level monitoring. Some of them have group level monitoring, and others even have outlet level monitoring of the actual power that's being consumed at the receptacle, if you will. Higher levels of aggregation are available if you go further and further upstream in an electrical sense, upstream from that final point of electrical consumption. If you move up to the UPS, or if you move up to other power distribution devices that are feeding power into your data center or data closet, that's where typically where you can collect up that information. It's not really relying on the server itself to have some sort of on the server's power management systems. Okay, my team here is handing me. We've got another new one. Let's see. Can we track the last? Aha. Yeah. Okay. So we've got one in here. Can you track devices by categories of like IP devices such as burglar alarms, IP cameras, locking door systems, turnstiles? So a lot of the the important final phrase here, all of those types of devices for use-based electricity billing schemes. I'm going to answer yes and no. So there are systems out there. In fact, we even offer a kind of a higher-end system that will collect a huge multitude of information from various power-consuming IP-enabled devices that might be deployed across your data center, everything from burglar alarms, IP cameras, that sort of stuff. Typically, when you get up into a class of product like that, what you're giving up on is some of the other elements of what we talked about here, like the ability to shut down, the critical shutdown function that we talked about, clearing out applications or shutting down applications, shutting down operating systems. You trade that in for the ability to go much wider and much wider into the physical infrastructure of the data center. So again, hopefully that's answering the question. Different kind of animal, but the answer is a qualified yes.
Well, in addition to the tracking devices question, there was a discovering device question posed by an audience member as well, whether Eaton can provide any device discovery help in the large.
Yeah. Oh, absolutely. Oh, yeah. Okay, I see that one now. Yeah. So, does Eaton provide any form of device discovery in large enterprise? Yeah, absolutely. That's certainly what our version of intelligent power management is all about. It has an auto discover feature, so anything that you've connected into that network will be auto discovered via the IPM software package. Okay, I think we're coming up on our time here, and I think the flow of new inbound questions here are kind of closing down. We've got one or two here that we're probably going to take offline with a couple folks, a couple that are still visible to me that we've already answered. So, Jenny, I think that we're going to draw this to a close here.
Well, let's do that then. Well, I want to let everybody know that in the next 24 hours you will receive a personalized follow-up email with details and a link to today's presentation on demand. And you can also just go and view today's event on demand if you visit www.netseminar.com. And if someone could just help push out the next slide, we'd just like to thank you, everyone, for attending today's webcast, Healing 8 Power Management Pain Points, which was brought to you by Information Week and Eaton. This webcast is copyright 2011 by United Business Media, LLC. The presentation materials are owned by or copyrighted, if that's the case, by Information Week and Eaton, who are solely responsible for the content, and the individual speakers are solely responsible for their content and opinions. On behalf of Jeff Ames and Lawrence Cruciana, I'm Jenny Zaino. Thanks for your time and have a great day.